Hey kids, hopefully you're enjoying your spring break as much as possible right now. Excuse my outfit, just got back from a run, decided it was a good time to do math. Our question is part A, number 10. This one's actually pretty similar to part D, number 11. In part D, number 11, it related the central angle within a circle to the area of the circle. In our case, part A, number 10, it's relating a central angle of 45 degrees to the perimeter of the circle. And I'll draw a little picture here. That central angle of 45 degrees gave us a perimeter piece, segment, if you will, of a pi inches. And we're actually talking about a slice of pie. I'm actually going to do this problem in two different ways. Being math, there's probably more, but these are the first two that came to mind. First way I'm going to do it is by building a proportion. 45 degrees we know is only part of the circle, so that would be 360 degrees is the total circle. And so then pi only represents a portion of the circumference, but we don't know the entire circumference, so I'm going to go ahead and call it x. Cross multiplying, we get 45x equals 360 pi. And dividing both sides by 45, we get an x value of 8 pi. So that 8 pi actually represents the circumference of the entire circle. However, circumference is not what we want. We want the radius of the circle. Here's where one of those formulas that should be up here, but it's also on the formula sheet, I think, on the front of test 3 and 4 on the SAT, the formula for circumference. Circumference, we know, is 2 pi r, and that will allow us to solve for that radius we would like. So we're going to divide, well, pi on both sides, really not doing anything, I can cancel it out. Divide both sides by 2, and we get a radius of 4, or option B. Now, like I said, there were two ways that came to mind, so I'm going to do this one more time. We still have that 45-degree central angle. And I'm going to think about what fraction of the circle that represents. So 45 degrees out of a 360-degree circle simplifies to 1/8 of the circle. So that actually means then that 1/8 of the circumference is pi. Now again, we don't want the circumference, we actually want the radius. So I am going to substitute in the formula for circumference into that c. I'm going to substitute 2 pi r. Now I'm going to go ahead and solve for r. I could go ahead and cancel out the pi on both sides, but I know that'll confuse some people because if I cancel pi, what's left here? It would be a 1, but for now I'm going to go ahead and leave it. 2 times 1/8 is 1/4. 1/4 pi r equals pi. We want to solve for r, so I am going to divide both sides by 1/4 pi. So we have pi over 1/4 pi, which really looks fun. Move this up here just so we can see a little bit better. Pi's cancel. So we have a radius of, we still have a 1 in the numerator, 1 over 1/4. And as much as I keep telling you all that you need to know how to simplify a complex fraction, here's one reason you need to. Answer some SAT problems. Flip, multiply by the reciprocal, that's gone. The 1's cancel, or you can just think of it, it's a 1, it doesn't really matter. There's another way we can get a radius of 4, or option B.